or substances that either accept electrons to become negatively charged or donate electron to become positively charged. Those ones that accept electron to become negatively charged, they are known as non-metals. While those ones that donate electrons to become positively charged are known as metals. Then cations, they are the positively charged ions, while anions are the negatively charged ions. When I say positively charged ions, I'm talking about Ca2 plus, Na plus, K plus. But when I'm talking about anions, S2 minus, Cl minus, O2 minus, these are anions. Then let's talk about the scientists that contributed in the development of the atomic structure. In an elaborate manner, I would like to discuss all the scientists involved as a separate topic. So in that situation, let's talk about deduce the number of protons, neutrons, and electrons from atomic and mass number of an atom. Now we're talking about protons, neutrons, and electrons. Now these are the components of the nucleus, even though we know that inside the nucleus we have protons and neutrons, while electrons revolve around the orbit. So what it means is that the protons is positively charged. Protons are positively charged. Protons are positively charged. They are positively charged. Why? Or you can write something like this as your proton. Why neutron has no charge. Neutrons, it has no charge. 0, 1, so it has no charge. It's 0 charge, so no charge. Why electrons are negatively charged, so that from their symbol -1, 0, so they are negatively charged. Proton is positively charged. Neutron is negatively charged. Neutron has no charge, is neutral, while electron is negatively charged. Now, you can be asked that why is the nucleus, or why is an atom said to be electrically neutral? You can be asked such a question. If you are asked that why is an atom said to be electrically neutral? An atom is said to be electrically neutral if and only if the number of protons in the nucleus is equal to the number of electrons revolving around the nucleus. What am I saying? Since we are saying that proton is positively charged and electron is negatively charged, an atom can be said to be electrically neutral if and only if the number of protons in the nucleus, that's the positive charge, is equal to the number of electrons revolving around the nucleus. In that situation, if you have your proton to be +1, and you have your electron to be -1, +1 - 1 automatically becomes 0. That is what is meant by electrically neutral. So it should be noted, because UTME can test that why is an atom said to be electrically neutral. So in that, if such a question is asked, the only answer to such a question is to say that the number of protons contained in the nucleus is equal to the number of electrons revolving around the nucleus. And another thing I want to also add here is that atomic number assumes this number of protons. So if you have to define atomic number, you will say that atomic number is the number of protons present in the nucleus of an atom. So in that situation, it means that the atomic number is a function or a measure of proton. While mass number is the sum of protons and neutrons in the nucleus of an atom. So, and the significance of this proton is that is the one that assumes the properties of an element. Imagine a case whereby you have, let's say, sodium as an element. You know that sodium is among the first 20 elements. To be precise, it has atomic number of 11, mass number of 23. In this situation, if I'm to know the properties of sodium, it means that I will need to know the atomic number. The moment I know the atomic number, and by Bohr model, it says that since it has atomic number of 11, then by Bohr model you have 281. So in this situation, I can say that sodium is definitely going to be what? Group 1 element, while period 3 element. You can see how I've been able to use the atomic number to deduce the group to which this sodium will belong, and also the period, because the group is telling us that the number group is a function of the number of what? Valence electron. So in this situation, the valence electron here, that's the outermost electron, is 1. That is why sodium will definitely be classified as a group 1 element. Then the period is talking about the number of shells. How many shells do we have in this situation? We have K, L, M. We have 3 shells. And the number in the period, element are placed in period based on the number of shells. So how many shells are we having here? We are having 3. But I will discuss that in periodic table more elaborately. So I just paraphrase here. But our major focus here is the chemistry behind protons, neutrons, and electrons. Now, apply the rules guiding the arrangement of electron in an atom. Now, if you are to go by this, in an atom, you have to arrange electrons in an atom. It is simply just like what if you pick any element, let's say sodium, or let's say element X. This side is always denoted by Z, while this side is denoted by what? X. It means that this Z is known as what? The atomic number, while this this X, or let me say A, this A is known as the mass number. Another name for mass number is atomic mass. Now, it means that since I said that the number of protons in the nucleus of an atom is the atomic number, while the mass number is the sum of protons and neutrons in the nucleus of an atom. That means by this formula I can say mass number A is equal to Z plus N, where A is the mass number, Z is the atomic number, and N is the number of neutrons. So if a question is given to us, let's say calcium 20 atomic number, 40 mass number, and the question asks us to determine the number of protons, number of neutrons, and number of electrons. In this situation, if you look at this very well, if you have to determine the number of protons, you don't need to do any calculation. Just go, since this is your Z is your number of protons, just go, you can see there is 20. So you can write 20 as the number of protons, which is the what? Atomic number. Then the number of neutrons, then you can use this formula to calculate number of neutrons. Atomic mass number A is what? 40. Atomic number Z is what? 20. Then you don't know the number of neutrons. So you can make this number of neutrons the subject of the formula. And when you do that, you have N to be equals to 40 minus 20. And in that situation, it will also be what? 20, number of neutrons. And let me tell you, number of electrons here is definitely going to assume what? Number of protons, that is 20. Take note. But a case whereby you are given this same species, but it is an ion in this respect, and you have 38, you have this, and the question asks you to determine the number of protons. Number of protons. Look at what you are given. Question asks you to divide number of protons, number of neutrons, and number of electrons. In this situation, we have to be very careful at this point. Now, the question asks us to determine number of protons. In this situation, number of protons does not change. Take note. No matter what happened to that species or that element, number of proton remain the same, because number of proton is the characteristic of that element. Take note. So here, number of proton will still remain 20. Take note. The number of neutrons. Number of neutrons here will be, because of the fact that, look at what is the difference between this and this, is that this one is an element, this one is an ion, and this one has lost 2 electrons. That is why you are seeing it as what, 2 plus. So when it loses 2 electrons, automatically the number of once it loses 2 electrons, it affects the mass number, but it does not affect the atomic number. So this one becomes what, 38. Then the mass number still remains, the atomic number still remains the same, 20, but the mass number will be affected. So if the question asks us to calculate number of neutrons, I will now say, since this is now the mass number, 38, atomic number, 20, plus number of neutrons. So number of neutrons will be 38 minus 20, and that will be 18. You can see that now. Then the number of electrons. What will be the number of electrons? Remember, this one is an ion that has lost 2 electrons. Initially, when it has not lost any electron, the number of electrons is 20. Now that it has now lost 2 electrons, what happens to the number of electrons? It now becomes 18. So in this situation, you can see that the number of protons remains the same, 20. Number of neutrons is now 18, while the number of electrons is now 18. What it means is that when an element changes to an ion, such as this, like a positively charged ion, it will definitely affect the number of neutrons and also the number of electrons. But number of protons is going to be constant. Here, we are asked to relate isotopy to the mass number. What is isotopy? Isotopy is a phenomenon whereby an element